Welcome to GMAT Math Online Math Prep videos. In this GMAT Math Online video, we explain primes and factorization. In an earlier video, we answered this question: is 784 a perfect square? We found the answer by finding the prime factorization of 784. 784 equals 2 to the 4th power times 7 squared. From this, it's easy to see that 784 is indeed a perfect square, because every prime number in its factorization has an exponent divisible by 2. Thus, we simply divide these exponents by 2 to get the square root of 784. Square root of 784 equals 2 squared times 7, and that equals 4 times 7, which equals 28. But the prime factorization of 784, 2 to the 4th times 7 squared, gives us a lot more information. For example, using its prime factorization, we can determine all its divisors. We just take all possible combinations of some of its prime factors. Here is the complete list of the divisors of 784. 2, 2 squared, 2 cubed, 2 to the 4th. 7, 7 squared. 2 times 7, 2 squared times 7, down to 2 squared times 7 squared, and 2 cubed times 7 squared. There are 13 divisors in all. Actually, there are more if we include 1, the number itself, 784, and the negative divisors, but those are obvious, so we omit them. Now let's ask some more questions. Besides 784 itself, are any of the divisors of 784 perfect squares? If so, which ones? To answer these questions, we again look at the prime factorization. From this factorization, it's not difficult to see there are 4 other divisors of 784 that are themselves perfect squares. These are 2 to the 4th, which equals 16, 2 squared equaling 4, 7 squared, which equals 49, and 2 squared times 7 squared, which equals 196. Now let's look at another problem that uses prime factorization. Find the smallest positive integer m such that 420m is a perfect square. And here are some possible answers. Let's find the solution. First, we obtain the prime factorization of 420. Since it ends in 0, we know that it's a multiple of 10, and 10 equals 2 times 5. So here's the first part of its prime factorization. 420 equals 2 times 5 times 42. But we also know that 42 equals 6 times 7, and that equals 2 times 3 times 7. So the complete prime factorization of 420 is 2 squared times 3 times 5 times 7. As you can see, we follow the standard practice of placing the numbers of the factorization in ascending order. Now the problem asks for the smallest integer m such that 420m is a perfect square. First, notice that the entire factorization of 420 must also be in the factorization of 420m. Next, observe that in 420's factorization, the exponent of 2 is 2, but every other exponent in the factorization is 1. So to make 420m a perfect square, we simply multiply 420 by each number that has an exponent of 1. That is, 420m equals 2 squared times 3 times 5 times 7 times 3 times 5 times 7, which equals 420 times 105, and that equals 2 squared times 3 squared times 5 squared times 7 squared. So m equals 105, and the correct answer is C. One more point. It's easy to see for this problem that 105 is the smallest valid value for m. But is there a larger value for m that would make 420m a perfect square? Actually, there are many. Here are a few. m equals 105 to the third power, 105 to the fifth power, 105 to the seventh power, etc. In each case, these numbers would make the numbers in the factorization of 420m all have exponents divisible by 2. Here are some more values for m that work because they use perfect squares. m equals 105 times 4, 105 times 9, and so forth. For more on prime factorization and its uses, see our other videos and go to www.gmatmath.online. And you can get our ebooks, GMAT Math Basics, GMAT Math Problem Solving, and GMAT Math Data Sufficiency. Thanks for your interest.